Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon everybody. My name is Dr. Muhammad Nur Azmi bin Muhammad Taib. I am the coordinator for this NMR machines, which is situated at the ground floor in front of our office. And for today, I would like to do some briefing regarding the NMR processing tools, which is top spin, and also some introductions, how you can prepare the sample NMR like this. Okay. So for today, again, my name is Azmi. So let's go. So this is about myself, nothing much interesting about myself. I just 5 years being here. So nuclear magnetic resonance, NMR, is a powerful analytical techniques usually used by organic chemists like me, natural product chemists. Anybody are doing inorganic chemists about, for examples, like anybody who are doing research with Prof. Yap, Dr. Rizal, you will use that one. Okay. Anybody also working on MOF, metal organic framework. Okay. It's used to identify the carbon hydrogen framework. Okay. Within the molecules. Okay. There are two common types of NMR spectroscopy. The first one is the 1H NMR to determine the type of and number of proton in molecules. The second one is 13 NMR used to determine types of carbon in molecules. Okay, so this is the general scheme for the NMR. Okay, we have workstations, okay, which is computer. We have NMR console, which is next to me. This kind I call the brain for NMR. And we have NMR conducting supermagnet, which is here. We have 500 megahertz. Okay, in northern regions, we have best facilities. Okay, now the system in USM we have 3 units. Okay, one in pharmacy, which is have a problem now. Okay, the second one at the iFarm. Okay, we bought a RBC, okay, by it's 700 megahertz. Okay, and next with us, okay, chemistry, we have actually 300 megahertz at the back, 400 megahertz for the solids after converting from liquid to solids. Now we already have to shut down because we don't have enough budget to maintain. And now the only left is 500 megahertz liquid. Okay, by next year we don't have any spare part, so we have to buy the new unit soon. Okay, so this is the units. I'm sitting here. Okay, I'm sitting here actually in front of the NMR machine. This is the consoles, the brain of NMR, and this is the spectrometer magnets. Okay, normally if you see this lamp is changed from greens, it means the system is okay, and suddenly when you observe change to red, it means they have a communication problem between console and also magnets. It means the experiment is failed. Okay, if you see the system in yellow or orange, they are in progress for measuring the parameters. Okay. Okay, this is a close-up about the NMR. We have the auto sampler here, which is we can put around 24 samples. Okay. Okay, for the sample preparations, okay, usually we weight not more than 20 milligrams. Okay, usually. Okay, and they have a few selections of NMR tubes, 5 millimeter diameters. Okay, between 5 to 3 mm diameters, 1.7 millimeters diameters, and also sugar tubes. And only for this unit, we have only used 5 mm diameters. Make sure you are using the correct size. Okay, so the third one is selection of deuterated solvents and reference. Okay, we have a lot of deuterated solvents, like in my hand now, we have acetone D6 here. Okay, So we have deuterium outside. Okay, so make sure you have to select the correct solvents. Okay, for example, you have to do the solubility test. Okay, for the all sample that you want to submit. And anybody are doing metal complexes, make sure you understand about the nature of metals, whether they are paramagnetic or dimagnetics. Okay, because if the metal give a response to the magnets, it doesn't give any result for your spectrum. Okay, and the third one is the solvent levels. I will explain later. So this is kind of example of NMR solvents. Okay, this is belong to me actually in my lab. So make sure you are using deuterated solvent. What is the definition of deuterated solvents? All proton have changed to deuterium isotope. Okay, so for example, methanol D4, it's mean Me, okay, CH3, okay, H will change to CD3OD. Okay, that's why we call methanol D4, all in deuterated. Why deuterated? Because the difference, because NMR will give a response for the spin half NMR, spin half protons. Okay, it's mean the nature protons, not deuterated, because deuterated is half spin. Okay, it's one. The spin is one, not half. Okay, make sure you understand that one. Okay. So this is an NMR solvent chart. Make sure you understand and memorize. For example, in my group, we are using frequent fluorophore D1. So the reference peak is around 7.24. In bracket 1 is a singlet. Okay, if we run the proton NMR. Okay, if we run the carbon NMR, they will show around 77.23 is the reference peak. Okay, you will see a triplet, 3 peak. I will show the example after that. Okay, so make sure you have this kind of tables. Yeah, just type the NMR solvent check data, you will find it. Okay. Okay, this is kind of how we can prepare the NMR solvents. This is the gauge that we will use to measure and set up the NMR. Okay, and this is the spinner. This is your NMR tube. Okay, usually we are preparing your NMR samples like this. So wipe with soft tissues and make sure we fold the spinner like this and put slowly inside the spinner, because spinner have a hole like this. Okay, so we have to put slowly, make sure your NMR tube is not broken. We have a few parameters here, so we are around 3.5 nmm. This is the magnet will measure this range. That's why for the solvent sample preparations, the height for the solvents, it's around, the height for the solvent is around 4 to 3.5 centimeter only, not more like this. This is a very bad sample preparations. I will explain why. Okay. Okay, again, this is the spinner that we use. Why spinner is color is around black and white? Because in computer language, okay, we will use O and 1. Okay, O and 1. The yellow is 1, the black is 0. So the machine will calculate when we put the sample inside the probe, they will spin. So how we can measure how much it spins, how many times it spins by using 1 and 0 language. Okay. So that's why the color is black and white. Okay. Okay, this is the line that I mentioned to you. The magnet will measure in this range. That's why we need to prepare the samples around 3.5 to 4 centimeter only. Okay. Okay. This is not really good because it should be in between, okay, below this line. Okay. Okay, again for this these pictures. Okay. Okay. So why we have to prepare around 3.5 to 4 centimeter? Firstly, this is very important. Deuterated solvent is quite expensive. Okay, for the CDCA3, the cheapest one is CDCA3. 100 ml is around 600 ringgit. So use wisely. Okay, it's not cheap actually. For DMSO, thousands for 25 ml. Okay. So as I know, you will provide the school will provide around 500 ringgit virtual account. So use wisely. Okay. So this is the NMR experiment that we have in our NMR machines. Okay. Because you will ask why the NMR is 500 megahertz. It's good. Okay. Why for the carbon we are measured around 125. This is because the gyromagnetic ratio for carbon is lower than proton. That's why for the carbons we need more time compared to protons. Okay, number of scans. Okay, you can put all number of scans. Any number can divide by 4. Okay, we have 1H protons for protons, but you have to memorize the pulse programs. Carbon 13. Okay, we have a depth, 3 types of depth. Okay, depth 135, which is measure methyl, methylene, and also methine. Okay, depth 90 degrees, they will measure CH only, and depth 45, they will measure CH3, CH, and CH2. Okay, so for the COSY, they will use to measure interactions between neighboring protons. Okay. The easiest way for the benzene ring, for example, for the alkene chain systems. For the SSQC, you will measure the proton, which is the carbon, which is connecting directly to the protons. Okay. Meanwhile, for the HMBC, the correlations between proton and carbons between J2 and J3 correlations. Okay. In detail, you have to discuss with your supervisors. Okay. For the DECQ, which is the new NMR settings, we will measure all the CH, CH2, CH3, and C quaternary. And lastly, this is quite new. I think this one is the last 2 years experiments. This is 2D experiment at one time. Okay, and anybody who are doing nature product will use mostly the 2D experiments. Okay. Okay, NMR Topspin software. Okay, for my student Ain and also Arif, I already asked them to install the NMR Topspins. So what anybody who are using NMR, so I strongly advise please install as soon as possible. Okay, we give a free license. Okay, for 10 years. It's better to install now. I'm not sure because it's free now. Okay, previously during my time I have to pay around 90 euros for 1 year. Okay, so what you have to do is you have to register. Okay, in Broker website. This is the website. Okay, www.broker.com/en/product-n solutions nmr software.spin.html. Okay, make sure you register. So log in. After you register, you log in. If you are not registered, you have to register as a new user. Okay. So and after that, you are go to this website. Okay, or type in Google Topspin for Academia. So you have to install the software, download the software from the website, and also request the license to Broker. And after that, they will give you the key, and you have to install the key in your NMR software. They have 2 versions here, 3.6.2, which is quite old versions, and they have 4.0 series. So it's up to you which one you want to install, but I prefer 3.6.2. Okay. Okay. I'm not open the website here, so because I don't remember my key because there is in my laptop at my office. Okay. So for NMR result processings, okay, we are already finished to discuss how to prepare the samples. Okay. And it's around 3.8 to 4.0 mm because if you put solvent too much like this, it will affect you regarding the concentrations. And also it will give you, for the next experiment for the carbon and depths, for example, they will need more time. Okay. If you are preparing the samples to concentrate, there will be a drawbacks. Okay. For the proton NMR, they will give not very nice spectra. Okay, we cannot see the splitting clearly, how they are splitting. We cannot see it. But for the carbons, it will take a short time. Okay. Please be aware about this ones. For example, if you need to proceed for the proton carbons, it's better to prepare with the concentrated solvents, concentrated samples. If you want to get a nice protons, less concentrated is also okay. No. Okay, the best sample is like this. It's around about this. This one is around 3.8 to 4.0 centimeters. Okay. So, okay, for the NMR processings, after you install the NMR, make sure you are playing around with the software. Try to get your own spectra or for your own samples and try to playing around. For today, we will do a quick demonstrations for the NMR top spins, but I'm using 3.6.2. Okay, they have a lot of NMR top spins. Okay, this is the non-open source software. For example, top spin for Brooker, Delta for, they have only 3 brands for NMR. Brooker, Joule, and also variants. Variant is not such, it's already bankrupt with an mistake. There is only 2, Kane, Brooker, and also Joule. But we are using Brooker here. Okay, it's better to have top spin because if you install Delta, you cannot read the top spin data. Okay, there is this one, these 3 NMR Notebooks, ACD Lab, and Nova NMR. It's open source. It means any machine can read this NMR software. Okay, I strongly advise please install top spin. Okay, and also we have integrations here. Okay, we will learn about peak picking, phase corrections, for example, and calibrate axis to the NMR processing. So we will see whether it's important or not. Okay. Okay, step-by-step analysis, we will do proton NMR, carbon, after that, HSQC, cozy, HMBC, and noisy. So heads on, okay. So stop sharing here. And I will see for a while. This one. Okay, anybody who have questions before I proceed? Ada siapa nak tanya? Later, okay, later lah, tak apalah, okay. Okay, this is the NMR, 2D NMR. So for examples we have here. So they have a lot of way how you can call the spectra. The first one you can open directly from here. Okay, for example. So I open my folder here. Okay, for example, I will open this one. And to find the nice
we are talking of the nice. Okay, the sentence for the nice.
Nice, yeah. Kita cari NMR yang okay sikit. Supaya you all faham. Okay, this is Proton NMR for natural product samples. Okay, so first there is a lots of tab here. So we do one by one. So for example, we want to know the integrations. If you remember for KOT 222, kita ada pakai integration pakai ruler kan? Yang nak kira berapa proton this peak, you kira berapa tinggi, and after that, you divide with the smallest one, if any mistake, right? This one we already do it automatically for you. Okay, so how to do it? Pick the integrations. Go this one all one by one. How you can do this one? We cut into the short one. Okay, this is the whole integration here. We want to do one by one, for example. So we can click here. Okay, this one. Okay. For example, so for example, I assume this one as the one. So I make as a reference, I right click. We have so many choice here. Go to Calibrate Integral. So we type one. Okay, it's already calculated. Okay, it's mean this one you can delete, right click, also delete current integrals. This one, delete the current integral. Okay. So you know this one is number one. This is one proton. This is nothing. Delete current integrals. This is one proton. This is one proton. This is 6 proton. We will see how is it. Okay. This one is 4 proton. This is around 8 protons. Okay. And you have to refer back again the notes for KOT 222. You will know which one is the aromatic regions, which one is the aliphatic regions. For example, this area, this one, 4 below 4, 4 to 1, 4 to 0 is around aliphatic regions. 7 to 8 is for the aromatic regions. Okay, double bond and so on. Okay, my advice is when you get your NMR, please playing around with your own data. It's better rather than I give you my data. Okay.
Macam nanti kalau dapat data itu kan?
Okay. Okay, this is for integrations, okay? And don't forget, after you make any changes, okay, make sure you save. Return and save regions. Okay, you can playing around with all the parameters here. Okay, don't afraid. The data is there. You can save and playing around and do it again. Okay, so as I mentioned, so you have to remember the reference peak. Okay, for these experiments, we are using chloroform D, and this is the peak for chloroform D, 2.7059. This is not the correct values. And how you can do that? You just go to the calibrate axis. Okay, go to the C. Go to the calibrate axis. Go here, click. Okay, put the correct one. 7.24. Because I'm using chloroform D. Click OK. Okay, they will shift it and recalculate again. Okay. Okay, because this one is already moving. Okay, we have to do the peak picking manually. Okay, and correct everything is because we already changed from 7.20 to 7.24. It means if shifted, dia bergerak. Okay, you can buat correction balik. How to do that? You go to the peak. You ingat kan ke dalam NMR, bila ada kelas tu ada value dekat atas peak kan? Yang ni kita buat. So delete again, you will delete value, so you buat manual. Okay, you buat manual, so peak. Okay, tengok dia buat manual. Okay. Ni better lah you buat manual sebab machine ni kadang-kadang dia pening. I campur bahasa Melayu bahasa Inggeris dia buat manual.
Manual tu patutnya satu-satu pay lah.
Manual maksudnya you buat satu-satu pay. Okay, dah buat semua, save jangan lupa. Kalau you lupa save, you kena buat lagi sekali. Memang pening lagi. Okay, dah settle. Okay, for example lah, this is the for the protons. Okay, next we go for the carbon. Okay, open again. I minimize this one. Open again. Your data, you can open from here. Okay, so I cari balik data I.
Lepas yang kita dah share tadi, yang integration tu nak kena bawa balik ke atau mana?
Tak payah. Integration you tak payah bawa balik, dia ikut you. Okay. So we drag here. Proton ya, itu carbon ya. Data lama. Jangan tengok data lain. Okay, tengok data lain ada proton juga. Okay, kita tengok. Cari data lain. Okay, I panggil data I. So you can drag the folder and we show you the options. That's why I ask you to remember the coding for the experiments. For example, I want to run this one. This is the carbon. So as I said, this one is run with methanol. So they have different peak. This is the peak for the methanol, and you have to calibrate again. So it's okay. This is carbon. If you remember, the carbon is only one peak. And after that, you have to read the values. For example, this is the reference for, I have to check again, methanol D4. Okay. This is methanol D4. This is your peak compounds. Make sure you understand and remember the table, the solvent that you usually use. Okay. So just doing the same. For example, I already doing calibrate here. So you will see. You see, this is not peak, but they are measured as a peak. Right. So we have to do it manually. Okay, so how to do it? Again, go to the process. Pick. Padam semua. You buat one by one. It's better. Better. Okay. Ada dua peak. 2 peak, 3 peak. Kita tengok nanti. Satu peak. Jadi satu peak. Tengok sini. Okay. Okay, and after that, don't forget to save. Okay, so carbon dah, I nak proses untuk depth pula. Okay, depth I run satu depth je, depth 135, open, ada macam ni, depth. Di atas yang positif mode, dia CH3, CH2. C quaternary dia tak ada. Yang bawah ni, bawah negative mode is CH2 only. Okay. Normally what I'm doing, I'm overlay with carbon. So kita boleh tengok dia carbon kita tu CH2 ke CH3. Kita overlay. Okay, bila kita overlay kita nampak lah. Oh yang bawah ni CH2. Carbon ni CH2. Okay, fine. Lega lah. Yang timbul-timbul ni, yang keluar-keluar ni, yang ni dua berdalah ni, yang ni semua CH. Yang tak keluar ni semua C quaternary. Okay? To know more, I think better you discuss with your supervisor lah. Then know better. Because my project and your project is quite different. Okay? I just touch until 1D NMR. For the 2D, not many people are using. But when you are using, you are free to manipulate the data that you have in future. Okay, because we want to make this session is short. Okay, so any question? Siapa nak tanya? Okay, satu question daripada Arif. Dia tanya macam mana nak dapatkan data NMR. Okay, it's a good question. In our NMR row, okay, we have workstations, around 5 workstations. just bring the pen drive, sorry. French they panggil key. Okay, pen drive, you can directly transfer your data from our secondary computer to your pen drive. But make sure before you do that, please scan your pen drive, because it will affect the main computer, which is here, if they have a virus. Can use also Google Drive to do that, but I strongly advise use pen drive. Better. It's okay, it's up to you. So we have saya kena ambil satu kertas ya. Okay, we already create the folder for every supervisors. Okay, we have prepared the guideline here. So you can easily use the username that has been stated here and also the password. Okay, it's clear state in these sheets. Okay, make sure you know how to do it. Okay, anybody who want to submit the NMR, please use this form. I stop sharing lah. Dah habis dah. Please use this form. Okay, state your name. Okay, name just use the short one. Okay, for example, I use Azmi. Okay, it's okay. Okay, siapa nama contohnya Alicia. Okay, just use Alicia. Alicia Yoli when I use Alicia only because we have a lot of samples. And we are afraid we will key in with different names and suddenly the folder will go to different folder. It's better use the short name. Okay, like Arif. Okay, so sample name, put as simple as you can. Okay, normally for my students, I'm using, for example, my name is Muhammad Nurul Azmi. I'm use MNA1, version number 1, MNA2, version number 2. Okay. Don't use compound reaction with blah 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 blah. It's too long. It's not really nice. Okay. So please circle any experiments here. We already state here. Circle, and we already have a default setting. Okay. But if we need more time to measure, please mention in this box. For example, the default for carbon is around 1 hour. Okay, your experiments need 3 hours. Just write down carbon 13 here, 3 hours. Put a note here. Okay, so if you want to measure other nuclei, for example, who are doing hydrogen storage with Dr. Chua, normally they are using boron chemistry. So we can measure borons, or anybody you are doing with Dr. Anwar, they are measure usually the silica. So we can measure silica. Don't worry, but you have to measure this one. If the sample is not really stable and you need to run as soon as possible, please contact Mr. Fahmi and make an appointment first. Okay, it's better to do that. Okay, and lastly, the most important thing is the solvents. Make sure you mention the correct solvents. If not, the system cannot log and shim the samples. So the experiment will be failed. Okay. And the NMR room will be open from 9 to 4 p.m., 9 a.m. to 4 p.m. every day except weekend. Okay. So make sure you register your metric card in this form. Just dash the NMR rooms and send this form to the office for us to key in. Okay, so make sure you get the supervisor job for that. Okay, because we will close the room, the door, and you have to tap with your metric card to enter. Okay, we can see how who is using this rule.
Pasangkan digit.
For the 6 digit nombor ni kat sini, you kena tanya office macam mana nak dapat.
Tapi saya tak nak.
Ask go to do that. It's better to do that. Okay. Sample dah. NMR Top Spin dah. Okay, siapa ada problem nak install NMR Top Spin, boleh jumpa Arif. Boleh jumpa Arif. Dia dah install. So, dia dah belajar dengan dia punya senior. So, you can do that. Okay. Okay, I nak bagi nombor telefon Cik Fahmi. Ada apa-apa, boleh call Cik Fahmi. Okay. Yeah.
Saya nak hantar sampel atau ibu Cik Fahmi.
Yes, when you want to measure the samples, you have to mention Cik Fahmi because we have already 500 ringgit for visual account and we have to record that one, okay? Cik Fahmi is a 010-358-9500. Okay, 010-385-9500. Okay, boleh call dia untuk prepare your samples. Okay, for NMR, we have two types of slot. Day slot, okay, weekend slot, okay. Day slot for the short experiments, for example, for measuring proton, or any experiment that you want, it's less than 2 hours, we can run on that day, okay. For the long time experiments, for example, like Dr. Rizal's students, they need 24 hours, okay. We already open booking. Okay, we have a table sheet and you have to write down your name and so on. And you have to booking the slots. Okay, for that one, you have to contact Encik Fahmi. Okay, it's better to do that. But you have to berebut dengan kakak yang lain sebab first come first serve punya procedure. Okay, next. Lagi? Ada siapa nak tanya? Catherine ada nak tanya? These sessions will be recorded and I will post in maybe lah e-learning group maybe. We will see how it is.
Jadi data yang ini apa? Pada project e-learning tu.
Yes, I will do that or in my YouTube channel. Okay. Okay, you are free to come and consult with me for the NMR. So for running the experiments, usually Fahmi will do that temporary because Puan Alia is on maternity leave today. So make sure you discuss closely with your supervisors for choosing their experiments, right? Because the time is very precious, berharga. So once you dah burn you punya overnight slot, susah lah nak dapat lagi slot. Ada lagi nak tanya? Siapa nak tanya? Boleh type ke? Sebab kadang I rasa speaker ni tak okey lah. Siapa nak tanya? Last. Siapa nak tanya? 1. Siapa nak tanya? 2. Siapa nak tanya? 3. Okay. For this year, we are not giving you NMR tube and also solvents. So you have to discuss with your supervisors. Okay. I think that's all for today. Thank you very much. Stay safe, stay healthy. Sampai itulah sesi kita. Okay. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh. Jumpa lagi.
Yes, come on, shorty, let's go. Girl, I see you over there in the corner of the dance floor, and I know you're acting shy, looking at the corner of your eye. So I pick my heart up off the floor, move my feet closer to yours, catch my breath and I say, I'm the one you're looking for. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So don't wait no more, I'm more. I'm the one you're looking for, shorty. Oh, girl, I I see you over there hesitating, deliberating, you keep me waiting on a sign, looking at the corner of your eye. So I pick my feet up off the floor, move my hips closer to yours, catch my breath and I say, I'm the one you're looking for. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So don't wait no more, I'm me, I'm more. I'm the one you're looking for, shorty. I'll be the one you're looking for, shorty. So come on the dance floor and baby show me all your moves, all your grooves. Shorty, I got something to prove to you. So come on, take a little chance. Got me in a trance in just one glance. So don't wait no more, I'm me, I'm more. I'm the one you're looking for, shorty. So come on, dance a little dance, dance a little dance. Come on, dance a little dance. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So don't wait no more, I'm me, I'm more. I'm the one you're looking for, shorty.